exam. Okay, so polygons, it just means many angles. Okay. Everything that we've learned so far is technically a polygon. All triangles are polygons, all quadrilaterals are polygons. Everything more than 4 is also a polygon. So it's just a closed shape with the same number of sides and angles. Okay, that's important. We will deal with convex only. Okay, so you only have to worry about these. You don't have ones that cave in like that. That would be called a concave. So just focus on that. We have regular versus irregular. This is very important. What is regular? This is how you know something is regular. You need to have all sides. Do you remember what this means? Congruent, the same. Okay, all sides have to measure the same, and all angles have to also measure the same. If it fails, even one of these, right? If it doesn't meet both of these criteria, it's not regular anymore. It goes into the irregular camp. Okay? So equilateral triangle is a regular polygon because all 3 sides are the same and all 3 angles are the same. So it meets both criteria, check mark, check mark. A square. It has all 4 angles are 90. Check. All 4 sides are the same. Check, check. What about a rectangle or an isosceles? This is an isosceles. How many sides are the same here? Only 2. Okay. Sides, it fails there. Angles, it also fails. So both of them fail. That's why this is an irregular. I want to talk about a rectangle. Rectangle. I got this. All 4 angles are 90, correct? Angles, check. Hey, this might be regular. We're in the race for regular. But sides, it fails, right? These two are the same, these two are the same, but not all 4 are the same. So it is in the irregular camp. So you have to make a line here. You're either on this side or you're on that side. Okay. What about a rhombus? All 4 sides are the same. Good. But all 4 angles are not the same. It would be irregular. Okay. I hope you understand that. Okay. That's all. And the province will find clever ways of asking you whether or not you understand the difference. It could be multiple choice. It could be, a scenario where you have to explain why this is regular. You just have to know that that's what needs to be met. Okay. Continuing. Watch this part. All polygons have interior and exterior angles. I'm going to use two different colors for this one. So you have your interior angle and you have your exterior angle, i.e. Okay. What do I mean by that? I want you to think of it this way. From now on, thinking of all polygons all shapes you've dealt with. Let's count the number of sides. I do a check mark on the first one I count to make sure you don't double count. Okay, so 1, 2, 3, 4, 5. 5 sides. And therefore, it will have, how many interior angles do you think this thing will have? The interior angles are right here. Count them if you don't believe me. 1, 2, 3, 4, 5. 5 interior angles. How many exterior angles do you think this will have? Wild guess. 5. The exterior angles are not something we're very familiar with, even though we just touched on that actually. Okay, so here it is. This is I. These are all interior angles. You ready for this part? This is going to blow your mind. Okay. You pick any of these sides at this corner right here. I'm going to pick the base one. You travel along it and you continue traveling in the same direction. You don't take the turn, you keep going along the bottom here. If you need a ruler, that's probably best. Just put a ruler right against that side and just extend it. That is where your exterior angle is, right there. So at this corner, you have an interior, you have an exterior. Right? Just watch what I'm going to do now. I'm going to go along this side, travel up here to this intersection. Instead of taking a turn, I'm going to continue. And that's where my exterior angle is. So can you tell that there's going to be 5? Yes. Okay, thank you. Nobody has that high-pitched voice in this class. There you go. That's exterior right there. And just keep going. Just keep going. Every intersection has one of each. Okay. And let's highlight. This is my exterior right here. So pretty. And the interior angles, I'm going to mark those orange. You get it? What do you think these two angles are going to add up to every single time? 180. Okay, good. That's where this statement is here. The interior angle plus the exterior angle will always add up to 180. Always. Interior angle and the exterior angle always add up to 180. This doesn't look like a regular polygon, does it? I did that on purpose because they're not all regular. It could be anything. It still works. Another one that I want you to highlight, watch this. Sum of exterior angles is always 360. So watch this. If you were to add up all the green ones here on the outside, it's always 360. Always. You can have a 500-sided polygon. Whoa, right? 500 sides. If you were to add up all the exterior angles of that 500-sided polygon, it would always be 360. Okay? So this is worth circling and highlighting. Okay? Comes in handy. Now let's go to formulas. Also, if you could take out the green formula sheet that I gave you at one point. Because I don't want you to, take up precious space on your study sheet if you don't have to. Formulas that I'm about to give you, all of these ones right here, you can write on this, I don't care. Just don't rely on having this for the exam. You get the formula sheet, but if you write on this, don't think you're going to be able to sneak this in. It just won't work for you. But here are all the formulas that I'm about to give you. What does N stand for? Every time you see an N, because it's quite popular, as you can tell. What does N stand for here? Number of sides. Okay, let's go. Here they are one more time. So watch carefully. The only thing is it does tell you what they stand for. The sum of interior angles, if you want to know what that is, use this formula. If you want to know the measure of each interior angle, you're like, what is S of n, Mr. Dirksen? I don't get the n part. Don't worry about that too much. I'll show you in a bit why I have it there. C of n, that's the central angle. I'm going to show you where it is because you need to know where it is. And exterior angle, 360 divided by n, calculates the measure of each exterior angle. Last but not least, this was on last exam, to be honest. This one right here calculates the number of diagonals that can be drawn. It's this formula right here. But the only key is here, you need to know your number of sides. You see ice right here. These ones only work with regular polygons. Can you highlight that? Ice. So maybe on your study sheet, I don't know if that it should mean something to you because it's not going to be that long ago that we will have talked about this. But ice only works with regular triangles. So let's use these and see when do we use what. Do you notice that central angle and exterior angle have the exact same formula? You will have the same answer for both of these. Okay. I'll show you where you can find them. Ice you can actually find and label. Here we go. It says label ice, then calculate psyched. You're psyched. I just did that. I tried something, whatever. It doesn't spell psyched, but that's what I was thinking. For the following regular polygons. Okay, so here's that. How many sides does this have, guys? That's the first thing you need to do. 1, 2, 3, 4, 5. N is equal to 5. Make sure you tell yourself that right off the bat. 5 sides. Just show me where one interior angle is. You go like this, anywhere on the inside, but just one. And just put a capital I there. You're in business. Where's the central angle? Folks, this is how it is. You go to the center, center, and then make a slice of pizza, right? So you go to one corner, you go to another corner. From the center, that's your slice of pizza, right? So that angle right there that you've just formed is what we call the central angle. How many central angles do you think you can draw with a 5-sided? 5, right? You could make one here, one there, one there. There's actually 5 central angles inside that shape. Exterior angle. Let's find the exterior. You go to any corner and you extend it. This is what I've seen on exams, okay? I don't know the name of the student. I will not disclose it. That is wrong. Think of it this way. You have to line up with this side or that side. I don't care. But you have to extend that side, okay? So this would be wrong. Just go with your ruler and just extend it like that. And that is one exterior angle. So you've identified ice. Interior, central, exterior. But now we're going to calculate. You got to copy this, at least have one good example here. Sum of interior angles. Remember, this means adding up all the interior angles of the shape. We use this one. Sum is equal to n minus 2 times 180. This one has 5 sides, right? So you go 5 minus 2 times 180. This is 3, right? 3 times 180. And just use your calculator. 3 times 180. It's 540 degrees. This is usually a bigger number because you're finding out what all of those interior angles add up to. You cannot label this one, right? This is not just one angle. This is like all 5 of them together. Next, we're going to do interior angle. A measure of each interior angle. That's what I'm going to do here. I'm using this formula. I is n minus 2 times 180 divided by n. That's what that formula calls for. Do you see this part already? Have we used n minus 2 times 180 before? It's right here. So we know the top is going to be 540. We're going to divide it by the number of sides because we want to split that sum of 540 equally amongst every single angle. So let's use it. That'd be 5 minus 2 times 180 over 5. And you notice that I take way too many steps, but I want to make sure I don't make a mistake in typing this in. So this would be 3 times 180 divided by 5. Now that it's cleaned up, you can actually type it in one shot. I know 3 times 180 is 540. And I'm going to divide that equally into 5. So 540 divided by 5, 108. So I is equal to 108 degrees. I'm going to block that off there too. What does it ask for next? The central angle. C is equal to 360 divided by n. Hold it. Does it make sense that it would be 360 divided by n? Because look at central angle. 360 is a full circle, correct? And you just want basically a fifth of it. So you're going 360 divided by the number of sides. 72, right? And let's do right next to it the exterior. It will be the same, correct? If you've been paying attention, it's the exact same formula. So it's 360 divided by 5, and that is 72. It's supplementary. Yeah, you see how exterior and interior add up to 180? What did I use? Orange and green earlier, right? Orange, you glad it's Friday? Anyways. So technically, you could have found the exterior angle by going 180 minus I. Like once you know the interior angle, you could have just subtracted it from 180 and gotten the exact same results. Got it? It's kind of like your backup method of doing it, maybe faster for some of you. So keep that in mind. So this is kind of like an or here. Or you can use this way. This formula is not on your formula sheet, this one. This is just a concept you need to know if you want to use it. I don't have room for D. Sorry. Do you have room for D? No. It's okay. We'll do it for the next one. We'll do it for the next one. We're good? Let's go to 52. Can I ask you to do everything except for D? Unless I think you can handle D at this point. So go to B. What's the first thing you're gonna do, guys? Brave volunteer. When you have a polygon, what should be the first thing you do? Count the number of sides. Can I please ask you to do the check mark thing? It sucks when you do this right, like the work is perfect, but you miscounted your number of sides, like on the exam, because you're nervous. So just go like, I'm gonna start with this one. So that's your number one, right? And then you know to stop just before it. So count the sides, label ice. I want you to label it, like actually put it in this. There should be an I, a C, and an E clearly labeled. And then calculate all those things. If you're able to do that, you're in pretty good shape with polygons. I'm just gonna go a few more examples. You counted for me already. Everybody said 11, so I'm just gonna go with it. 11 sides, perfect. Let's go identify any corner, go to any corner, make a little bit of an arc and call that I. Then go to any corner of your liking, and like if you pick this corner, you travel along one of the sides and just keep extending it the same direction. Okay? That is E, that's one exterior angle. And central, you just go to the center, make a dot, and just connect it like that. That opening that you've created is a central angle. So there we go. You've got labeled them, and then for some of you were worried about the big numbers. Don't fear that. That's normal. Okay, that's 9 times 180. What is that? 1620? Yeah. Okay. Thank you. There we go. And for the interior angle, let's use the space wisely here. For my interior angle, it's n minus 2, so 11 minus 2 times 180 over n. Okay, so it shows up twice. That's 9 times 180 over 11, which is 1620 over 11. What is that? Don't round, okay? I know that some of your teachers in the past for trig, they rounded an angle to the whole number. Don't do that in this course, okay? Like the province always wants 2 decimals. So that's the measure of each interior angle. Just listen to this part. The more sides you have, the bigger this angle is going to start getting. Because like, can you imagine 1,000 sides? It would start looking like a round circle, right? So that angle, like the angle, the opening right here, it gets bigger and bigger and bigger the more sides you add to this thing. Okay? Therefore, your sum is also going to get bigger the more sides you have. Okay? Let's do exterior. That's 360 divided by 11. That is 3273. Central angle is the same thing. 3273. I've done S, I, C, E. This is the D, guys, okay? Diagonals is n times n minus 3 over 2. You got to be careful with this. This is not a degree. This is not an angle, number of diagonals. So you would go 11 times 11 minus 3 over 2. Clean it up a bit. 11 times 8 divided by 2. 11 times 8 is 44, 88 divided by 2 is 44 diagonals. You could easily lose half a mark if you don't pay attention to that. Can I just show you, I'm going to show you a very quick example of diagonals. Make a pentagon with me, okay? So you basically make the roof of a house, and then you just slant in the walls a bit, and you go like that. Diagonals are as follows. If you connect this one to that side, this one to that side, that would be 2 already. You could then go to another corner and say, hey, I'm going to connect this one. Come on, work with me here. Not today, not today. That's it. That's 3, 4. I'm missing one, right? You see it? Right here. How many diagonals does this pentagon have? 1, 2, 3, 4, 5. Can you imagine actually having to draw it? You'd go crazy, right? I would go crazy. So for a pentagon, it would be 5 times 5 minus 3 divided by 2. So that's 5 times 2 divided by 2. 5 times 2 is 10. Divided by 2 is 5. There's a little aside here for you. So number of diagonals, that's what we mean by it. So guess how many you can draw with the shape you just worked on? 44, right? So good luck keeping track of that. So I would not recommend it, but the province says you're able to show your work by drawing the number of diagonals. You can. I would not recommend it because if you're off by even one, it's wrong. And I don't want to count 44 diagonals. I do not want to do that. So just don't do it. Go to with a formula. Same thing here, a 30-sided regular polygon. Well, guess what? N is 30, copy paste. Yeah. Where are we at here? Okay. I want to do this one yet because this one doesn't tell you what the angles are that it's trying to find. It doesn't give you a name for them. So let's go here. I would really want you to write this down. Okay. It says calculate the value of the indicated angles. What is angle A? What would I call this one? Interior. Yes. So let's find that one first. How many sides? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. N is equal to 15 sides. That's where it all starts. So angle A is an interior angle. Okay, keep that in mind. So angle A will be N minus 2 times 180 over N. I'm putting down the formula. So this would be 15 minus 2 times 180 over 15. Angle A is 13 times 180 over 15. And now you use your calculator and away you go. 13 times 180. What's going on here? Divided by 15. 156. Exactly. So that's kind of nice. Angle A is the measure of one interior angle, which is 156 degrees. Not too shabby, right? I will do C next. Angle C is actually an exterior angle, right? Angle C is an exterior angle. So angle C is simply 360 divided by N. Angle C, wait a minute, is there another way to do this? 180 minus 156 would give us this too. Okay, just letting you know that it's still available. Divided by 15. So that is 24. Angle C is 24. Here's where you need to pay attention to this one. Angle B is not a central angle. I don't know if you've noticed that. Angle B is, how many central angles are in here? C and C, correct? two central angles. All right. So this is how I'm going to find angle B. Angle B is 2 times a central angle. Let's find C. Angle C, just a central, is 360 divided by 15, which we already know is 24 degrees. We've done that before. So angle B is 2 times 24. That would be 48 degrees. There we go. Now, I want you to go to #55. I want you to work 55 to 56 right now. Hold on. I need to do something else yet. Sorry, guys. Can you go to 54? I know it's Friday, and I know you're tired. I know. But I need to do this. Otherwise, we're going to be in trouble. 54. Let's take a 2-minute break so you don't have to listen to me. Way more than 2 minutes, I know. You liked it. I was hoping for 10 more. Does working backwards mean anything to you at this point? Formula, but yeah, what's the thing that you use to calculate is going to be given to you. Okay, that's what that means. So let's see if we can figure this out. The sum of interior angles of a polygon is 30, 60. Determine the number of sides. Like they're asking you, how many sides does this thing have? Okay, and so they're basically saying that S is equal to 30, 60. You know, when you used to calculate S, the sum, they give this to you. You cannot do, it's not acceptable to just try until it works. Okay, some students will attempt that. So you got to go sum is equal to n minus 2 times 180, correct? That's the formula. You're going to plug this in here on the left side. So you go 30, 60 is equal to n minus 2 times 180. Here you have choices, but I'm going to give you the easier choice. I'm going to see the goal is to get to n, right? So first we're going to get rid of the 180 that's multiplying it. What's the opposite of multiplying? Divide. Okay. Cancel, cancel. Love doing that, right? I wish I could do that with my loan. 30, 60 divided by 180, that's 17. And you're left with n minus 2 on the other side. You don't have to have the brackets anymore. Yes, plus 2, voila, you're there. This one is probably one of the easier cases. This is 19. So 19 sides. You could double check this. You could actually plug this into a formula and see if the sum is actually 30, 60, and you're in business. One more. This one I find easy as well. A polygon, a regular polygon, we're told, has exterior angles of this. This is E. Calculate the number of sides algebraically. So what is n? What formula are you going to use? Well, you go check, right? E is equal to 360 divided by n. That is the formula. You plug this in here. So that'd be 11.25 is equal to 360 over n. What does this look like? You've done it since grade 10 for sure. Right? Cross, multiply, and divide. But Mr. Jackson, it doesn't quite look like it. Wait for it. Wait for it. Now it does, doesn't it? Okay. Cross, multiply, and divide. So n is equal to 360 times 1 divided by 11.25. 32 sides. And this one is super difficult. Unless you do what I'm going to show you, the trick. A regular polygon has interior angles of 179. Interior, that means that I is 171. Correct? Calculate the number of sides algebraically. It's like, what is n? Aiden is awake. Okay, you can use this formula if you want. Watch this. This is interior angle. Does that look like fun to work with? What do we know about the interior and the exterior angles, folks? They add up to 180, correct? So I'm going to say, well, wait a minute. I can find the exterior angle, which is 180 minus 171. It's 9. Okay. And now you're back to this example right here where you just use the exterior angle formula. You plug in 9 here. So that's 9 is equal to 360 over n. And then you just put a 1 here. So it's times divide. So it's 360 times 1 divided by 9. That's 40 sides. You're not finding degrees when you're doing backwards. When you're finding n, you're finding number of sides. You can use this one. I know some of you will. You just have to be careful, right? Because it gets kind of messy. I have nothing against it. It can be done, but I would resort to this method. Okay. Oh, time is out. Okay, I'm going to stop here. Your take home